Hello, geometry students. It is lesson 3.8. We are now looking at what we're calling challenging proofs, which kind of means you have some like overlapping proofs. It can be a little tricky to look at. I would strongly suggest today, I have a blue pen, a highlighter, I've got a red pen. Different colored pens and pencils is going to be super useful for today. So if you need to pause and go grab some stuff, I would do it, all right? So on the first page is meant to be just some quick practice. So when it says name the 5 postulates that can be proved or used to prove that triangles are congruent, by now, these should be easy. So it doesn't matter what order you write them in, but the idea of, side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. All right, that should be easy at this point. For each of these are just kind of checking in with you. State the postulate that can be used to prove the 2 triangles are congruent. So you have to know to mark any reflexive, any vertical angles, and then take a look at one triangle and answer that question. So like number 1, we have to recognize, hey, I've got that reflexive, and then cover up. So yes, I have a right angle, but I don't have the side opposite. So if I don't have the hypotenuse, this is an HL. This one's simply side, angle, side. Right? So that's it when I look at one like number 1. And then you'd be working your way through the rest of them. So like when you look at number 2, again, you get that little reflexive piece. And then when you cover up, you have 2 angles and a side. But in this case, the side doesn't connect in between. It's over here. So this is a perfect example of angle, angle, side. I'd like you guys to try the rest of them here, and don't be surprised if your post-video question has a little something to do with the remaining ones that are sitting here. All right. We'll talk about them tomorrow in class as well. Let's take a look. Let's jump right on in to some of these guys here. So the very first one, you've got an isosceles triangle, AEB. So that's the big triangle here. They're telling you angle EAD. This angle is congruent to angle EBC, this angle right here. And we're going to prove that triangle ABC, so where the heck is that? ABC, at the bottom, is congruent to triangle BAD. So to me, I'm really visual. It helps me if I can break it up with some colors. So that's what I'm going to do right now. So I'm going to just highlight triangle ABC. So ABC is this guy here. And it doesn't obviously have to be perfect. And then I'm going to grab my red pen. I think this one's working. And I'm going to try highlight BAD. The other thing that you can do when you have triangles that overlap one another is it's also sometimes helpful to redraw them. Now, the redrawing doesn't have to be like perfectly accurate, but I can kind of sketch and say, okay, here would be B, A, C, and then I'm going to redraw the other one so that I have here's like A, B, and then maybe D would be up here. So I end up with like a little something like that. So you can do both. You could do just one of those, but I do think it's helpful to kind of see it, all right? So when we start with the very first given, that the big triangle's isosceles, you always want to keep in mind, like, where are we trying to go with this, all right? So here we've got triangle AEB is isosceles with base AB. All right. And now again, I could put my other givens, but since I've got so much room, I'm not going to rush things. So I want to start with the isosceles. So isosceles, I know, gives me either 2 congruent sides, which would be those big old sides there, or 2 congruent base angles. In this case, the sides don't seem to be doing too much, especially because they didn't give me anything else to maybe work from like that big side down to this little side using maybe subtraction postulate. So I'm going to ignore the sides. I'm going to go straight to talking about the angles. So I'm going to take this vocab term because, I still want you to focus in on that vocab and roll with it. So if I have isosceles there, that carries right here. And I'm going to say that an isosceles triangle implies that I have 2 congruent base angles. So the base was down here, which means my base angle is this big angle here and that big angle right there. So that's going to be angle. This is where you definitely do not want to use numbers. There's too much going on there. Use the letters. All right. So I can say EAB and EBA, or it might even be a little bit simpler to think of it as CAB. So you can do it either way. Actually, maybe I'll stick with the original EAB and then EBA. The only reason I was saying adjustment is so you could see that like it's definitely in that triangle. So mark it over here and mark it over here. That's one pair of angles right there. Right? So it's a little tricky to see in the big picture, but when you separate it, it makes it pretty easy to see what's going on. All right. If I go to my next given, they give you that angle EAD, oops, is congruent to angle EBC. All right. If I look in the picture, angle EAD is that skinny little angle right here, and EBC is that skinny little angle. If I look at that with the separated triangles, that would be like part of this angle and part of that one. It does not hand you a pair of angles in the triangles you're trying to prove. But if you look back at the picture where they overlap, you have this whole angle congruent to that whole angle. I have this part congruent to that part. If we use the subtraction postulate, we can get this remaining little part here, which why is that helpful? Well, that angle is angle DAB. Come over here. That's angle DAB. That's this guy. And if I subtract the smaller angle from the big angle, I'd be left with angle CBA. CBA is that little angle right there. All right. So we're going to get a little crafty here and use some subtraction postulate. So remember, this is the big angle. That's part of it. So we're going to take the big angle, EAB, minus part angle, EAD. And we know that that's going to be congruent to the big angle, EBA, minus part of it, angle, EBC. All right. That is our subtraction postulate. That's going back a ways. We haven't really looked at some of those in a little bit. All right. When we, oops, got a little ahead of myself there. When we subtract, don't forget, you got to rename it. That's the whole point of it. So underneath this, you can use curly brackets or a straight bracket. When I take the big angle and subtract this little part from it, I'm left with angle DAB. And then over here, when we take the big angle, let's see, EBA minus this guy, you're left with CBA right here. Okay, that gives us a pair of angles in our triangles. So now when I look at my separated picture, I'm going to slide for a moment. My separated picture, I've got this angle congruent to that one, and I start it, which I know is weird notation, but whatever. I got that angle congruent to that one. Okay, we are out of givens. This is where looking at the original diagram helps. You're usually looking for vertical. Those two vertical angles are not going to help me because that's just floating around on the inside of this triangle here and this triangle here. But if you look, because the triangles overlap, they share that bottom side. So they have this side AB in common. So we can actually use the reflexive property. So I'm going to come back up so that you can see. And I'm going to say that side AB is congruent to side AB by reflexive. And something to keep in mind as we're going through the proofs, there are things that we abbreviate. We use the symbol angles often for the word angles or triangles, for the word triangle. But please make sure to fully state over here. I always want to see like isosceles implies two congruent angles. Don't just write isosceles, all right? And subtraction postulate, reflexive property, all right? The fact that we are already just writing this as two columns and not as like full paragraphs, which would be the alternative, means that we're already abbreviating plenty. Okay, so I don't want to make it any more of an abbreviation. Just wanted to mention that. All right, AB congruent to AB. That gives us a pair of sides in our triangles. All right, bring it back up top. Let's take a look at that diagram. If we look, the nice thing is they're separated. Here's two angles and the side directly between them. This is going to be a little ASA right here. So we can say that triangle ABC is congruent to triangle BAD by a little angle side angle congruent to angle side angle. All right. Yeah, and if you didn't realize, that would be the alternative, you guys, to writing 2-column proofs, would be to write out in a paragraph to say, like, these triangles are congruent because of, and you would have to write it all out. So this is our nice accepted abbreviated format, which I greatly appreciate. All right, we have one more. Let's flip over and just take a little look here. If we kind of set this guy up, at least for number 2, let me slide so you can see everything. We have the AM bisects segment DC. That's a good one. We got angle A is congruent to angle B, and we have angle, holy moly, AMD congruent to angle BMC. All right. It's a very cool diagram to look at, but what's super useful is to look at what you're trying to prove, and let's outline that. So we're trying to prove at the end of this that triangle AMC. So I'm going to use one color. So I'm going to stick with my blue pen here for a second. AMC. That guy is congruent to triangle BMD. So I'm going to grab my red pen here. Now, if you have colored pencils, this is a great place to use them. You can color in, you can trace out, whatever works best. And you may want to bring them to class as well, as it's pretty useful to have there. All right, those 2 triangles are what we're looking at. So even though, and I know I redraw this, it's not going to look that nice, and that's okay. I'm not going to judge myself. I know that if I just redraw a little like mini version of it, here's my red triangle. So it's D, M, B. And then I have the bigger triangle. Oops. Which is M, C, and A up there. Okay. Ooh, mine are definitely different sizes, but that's okay. So get that drawn so that you're set to go. Right? And then I think what we're going to do, let me see really quick. I think it might be a good idea to hold off and do this one together in class tomorrow. So make sure, go answer that post video question. Make sure you have the diagram set up and ready to go. If you're feeling, like you want to give it a try, feel free. You could get that first given in there and take a look at it. Otherwise, we'll start with this first thing in class tomorrow. Thanks, guys.